So we want to find the acceleration of the crate as well as the final velocity. So let's draw the incline. Excuse me. So we have a theta here, and we have a crate, mass of m. We have force normal, perpendicular to the slope, and then we have a force of gravity going straight down. And in the direction opposite of motion, we have force of friction. So we can say that sigma, also we're using our Cartesian axis is like this. So this is our y, and then this is our x. So we can say that sigma Fy equals 0 newtons because the block isn't moving off the incline. So it's going to be traveling in the x-axis only. And this is equaling force normal minus the y component of gravity. In this case, it's going to be mg cosine of theta. So we can say that f sub n, force normal, equals mg cosine of theta. We can apply this in the x direction and say that sigma fx equals ma. And we can say that this is equaling the x component of gravity, so mg sine of theta, and then it'll be minus the force of friction. We also know that the force of friction simply equals mu k Fn, so the kinetic coefficient of friction times the normal force. And so we can say that mg sine of theta minus mu k mg cosine of theta equals ma. So we're going to eliminate the mass. And we have that a equals g times sine of theta minus mu k cosine of theta. And now we can plug in. So it'll be 9.8. Then it'll be sine of 25 degrees theta minus the coefficient of kinetic friction is 0.19. And then this will be times cosine of, again, 25 degrees. And this is giving us acceleration 2.454 meters per second squared. So this will be your answer for part A, but in order to find the final speed, we can use kinematics. So we know that delta x equals 8.15 meters, which means that we can simply do Vf equaling radical 2a delta x, and this equals radical 2 times 2.454 times delta x of 8.15. Extend the square root a little bit. And we have a final velocity equaling 6.32 meters per second. This will be your answer for part B. That is the end of the solution. Thank you for watching.